Welcome back to another lesson in which we continue our studies of finding square roots, and more broadly, studying root finding algorithms. Last time we talked about Newton's method. Today we will talk about the secant method, which is in fact very similar but different in significant ways. Here I've drawn a picture of a function including both Newton's method in blue and the secant method in red. Whereas Newton's method takes the derivative at a single point and extends a line to find the intercept on the x-axis, the secant method requires 2 points and finds the intersection on the x-axis. Now this is advantageous because the secant method does not rely on directly finding the derivative. So in cases where it may be difficult to find the exact derivative, the secant method is incredibly useful. Notice even the form looks very similar to Newton's method. We've simply replaced f prime with m for the slope, where m is effectively delta y over delta x, as we've seen in our lessons on linear functions. So what does this look like in implementation? Let's find the square root of 10 using the same f of x is equal to x squared minus 10. I represents which iteration we are on. So I0 is our initial guess. For this initial guess, it doesn't matter too much what I put, with some caveats we won't discuss here. I'm going to choose 4. When I plug that into my function, 4 squared is 16, minus 10 is 6, f of 4 is equal to 6. I must also input a number for x1. Again, this doesn't matter too much, so I'll just choose 3.5. 3.5 squared minus 10 is equal to 2.25. So now I have 2 values for f and 2 values for x. I can plug those into this formula to compute m1. So I take 2.25 minus 6, divide by 3.5 minus 4. As I've summarized down below here. That answer is 7.5. Go ahead and verify on your own calculator that this number is correct. My next step is to plug the numbers into this equation, as I've done below here. x2 is equal to x1 minus f of x1 divided by m1. So that is 3.5 minus 2.25 divided by 7.5, which is equal to 3.2. So I fill that number in on the table here. Evaluating 3.2 squared minus 10 is equal to 0.24. 0.24 minus 2.25 divided by 3.2 minus 3.5 is equal to 6.7. 3.2 minus 0.24 divided by 6.7 is equal to approximately 3.16417904. By continuing the same pattern, I can complete this table, as you see here. Plugging x squared minus 10 for f of x, and m is this minus this divided by this minus this for each iteration. Notice my value for x, representing the square root of 10, converges to 3.162277660. which matches our answer from the calculator. Meanwhile, look at what's going on with f of x. This number is getting very, very close to 0 as we converge on the value of x. Also notice my column for the slope seems to be converging on a value somewhere around 6.3. If we carried out more and more iterations, this number should also become a constant around 6.3. I encourage you to pull out a calculator or even use a computer spreadsheet to verify the numbers I've produced here. See if you can understand the algorithm and how to implement it to obtain these numbers. In the next lesson, we'll look at a unique application of the secant method. So stay tuned for that. Thanks for watching.